Good day, students. Welcome to math.serve.com. In this clip, we're going to be going through problems 25 through 27 of the Algebra 2 Trigonometry January 2015 Regents exam. All right, let's take a look at problem 25. It reads, the table below shows 5 numbers and their frequency of occurrence. So we have the numbers here and the frequency of their occurrence. The interquartile range for these data set is. Now, one thing you want to note is that the interquartile range is not the range of the data set. Okay? The interquartile range is the difference between the third and the first quartile. Now, these are the steps we're going to use for this problem solving process. First of all, we're going to split the data set in half to find the median. Okay? The median divides the whole data set into upper and lower halves. Now what we're going to do is we're going to split the lower and upper halves into 2 again to help us get the first quartile, which is the equivalent of the median when you're looking at the lower half, and the third quartile, which is the equivalent of the median when you're looking at the upper half. Okay? After finding the first and third quartile, we're going to apply the formula interquartile range equals quartile 3, or third quartile minus the first quartile. All right? So that's what we're going to do. Now, in a problem like this, there are different ways you can do it. There are some abstract ways where you can basically count and then divide the data set using the frequency. But the method I'm going to use the old-fashioned method. It takes a little bit longer, but I'm trying to be safe here. And I also want to make sure that everyone understands exactly what is going on. All right, this is a longer method, but there are quicker methods which I will not use in this presentation. Okay, all right, so to do this, what I'm going to do is I'm actually going to list the frequency of these numbers, every single one of them. Okay, so there's no doubt as to what's going on. All right, so for the number 5, we have the frequency of 9. What does that mean? It means that in this data set, there are 9 5s. Okay, so let's list them. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and then we have 5 7s. Let's go ahead and list that. 1, 2, 3, 4, 5, 6. Oh, actually 5, huh? So 5 7s, 1, 2, 3, 4, 5. Okay, got carried away with my counting there. And then we have 8 8s. All right, so let's list that. We have 1, 2, 3, 4, 5, 6, 7, 8. And then we have 8 12s. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8. It's a pain to write all these numbers down, but I just want to make everyone see exactly what's going on here, okay? And then we have 8 14s. Gonna have to make it fit somehow, some way. So we have 1, 2, 3, 4, 5, 6, 7, 8. Nice. Fits in perfectly. Okay, so now we have everything listed. Now it's easy for us to determine what's in the middle. And then we can split the whole data set down the middle, and then we go from there. All right. Now, one thing you want to note is that when you have an even number of elements in a data set, you have an even split. So what you have to do to find the median will be to find the average of the two numbers, um, the two numbers in the middle. Okay, just average them out. But if you have an odd data set, then it's perfect because you have one number in the center. So how many numbers do we have here? We can count all of this, but to be quick about the whole process, we can just simply add these numbers here. 9 plus 5 is 14. And then you have 3 8s. 8 times 3 is 24. And then if you add 14 and 24, you have 38. So we have a total of 38 numbers here, okay? Now, where is the middle? Okay, so to find where the middle is, we're going to divide this by 2. Now remember, we indicated earlier that if you have an even number of elements in your data set, you have to find the average to determine the median. Okay, so observe this, 38 divided by 2 is 19. So if we split this data set down the center, we'll have 19 in the upper half and 19 in the lower half. Okay, so all we just do is just count from 19. Count 19 from the start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. All right, so here's 19. So what we're going to do is divide our entire data set into halves. So if this is 19, counting from here, how many numbers do you expect to the right? We should expect 19 also. Okay, let's just verify just to make sure we did everything correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Perfect. All right, so what is our median or second quartile? We don't have a number here. Okay, so what are we going to do? To find the median or the second quartile, we are going to have to average the numbers around the middle. Okay, so quartile 2 is 8 plus 8 divided by 2. Okay, 8 plus 8 is 16 divided by 2 um, is 8. All right, now we have Q2. What do we do next? Remember in our steps, we split it into an upper and lower half. So what we're going to do is we're going to look at the lower half. Look at this as a data set. What is the median of this lower half right here? Let me show you what I'm talking about. So you group this entire data set together, and then you ask yourself, what's the median here? And then you group this entire data set with each other, and then you ask yourself, what is the median there? Okay, so that's basically what we're doing. All right, it's like we're creating a new problem with two parts. Okay, so let's go ahead and find out what the median is for the lower half and then the upper half. Let me take the boxes out of there. All right, so we're gonna count. So we already know there are 19 elements here. So what is 19 divided by 2? 19 divided by 2 is let's do that. So let's define quartile 1. Let's put our work here. Let's find Q1. We're going to take the entire number of elements in the lower half, 19 divided by 2, and that gives us 9.5. The nice thing about having an odd number of elements in your data set is that you have a middle number, and that will be a median, okay? If it's even, they have to average. So what this is telling us is if you count 9 numbers, the next number is the median, okay? So the median in the lower half is actually the first quartile, okay? So let's go ahead and count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so break it up right here. And this number is going to be our first quartile. How do we know that this is Q1? Well, if we count after this, guess what we're going to have? We're going to have 9 numbers also. So check this out. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this number is our first quartile. Remember, every time you have an odd number of elements in a data set, you do not need to do any averaging to determine the median. Okay, you always have one number in the center, and then the remainder of the numbers are even, so you can split it evenly. All right. Okay, now let's find the third quartile. Can you figure out how to do this? Since we have 19 numbers here, we just count 9 either from the left or from the right, and the number in the middle is our third quartile, or the median of the upper half. Okay, so let's go ahead and do that. So we have, let's count from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So break it up right here and then break it up. Now, if I count, how many numbers do you expect to have here? We should have 9 numbers since this is the median, this is the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9. Excellent, that's exactly what we want. So this number here is your third quartile, Q3. Okay, Q3 equals 12, Q1 equals 7, Q2 is equal to 8. This is your minimum. It's not the first quartile, so be careful about that. This is your minimum, and this right here is your maximum. Okay, now let's go ahead and compute the interquartile range. Using the formula IQR, interquartile range is equal to third quartile minus the first quartile. The third quartile is 12 minus the first quartile, which is 7. 12 minus 7 is 5. Answer is option number 2. All right, let's take a look at problem 26. It reads, a wheel has a radius of 18 inches. Which distance to the nearest inch does the wheel travel when it rotates through an angle of 2 pi over 5 radians? Now, one thing you want to note is that when finding the length of an arc, the units of the angle, whether degree or radian, determines the formula to use. Okay, there are 2 formulas for finding the length of an arc, so you have to look at the um, angular measure, the unit of the angular measure to determine what formula to use. All right, so let me show you the 2 formulas. There is uh, arc length is equal to r theta, and this arc length is equal to theta over 360 times 2 pi r. All right, this one right here, S is equal to r theta, this is the radian formula. If your angular measure is in radians, as is illustrated in this problem, this is the formula you use. But if it is in degrees, you can either use this formula or you can convert your angular measure to radians and use this formula. Okay, so check this out. See this formula right here? This 2 pi over 360, that piece of the formula actually converts this theta from degrees to radians. Okay, that's pi over 80 upon reduction. Pi over 180 times theta converts theta from degrees to radians. So our theta will just be sufficient to compute the length of the arc when it's in radian measure. All right. Okay, so the steps for this problem are as follows. Firstly, we will write down the formula, determine the right one to use, and then we'll list what we need and what we know, plug it into the formula, and then determine what we need. All right, so let's go ahead and start with the first step. Step number 1, write down the formula for the length of an arc. Okay, length of an arc, since we're dealing with a radian measure here, we're going to use the formula S is equal to r theta. Okay, let's just put a side note here. Note theta is in or must be radian. If theta is not in radian form, either you use this formula or you convert to radian before you use this formula. So be careful about that. All right, let's list what we know and need. The radius. Um, let's see, what is the radius for this problem? The radius is 18 inches. So radius is 18. Uh, Theta, the angle, is 2 pi over 5 radians, or 2 over 5 pi, same thing. And then what is S? What is the arc length? That is what we're looking for, question mark. All right, so let's plug everything into our arc length formula from step 1 and use it to compute the length of the arc. Okay, so we're going to have S. Let's write a formula again. S is equal to r theta. So S is equal to the radius, which is 18, times theta, which is 2 pi over 5. Okay, and then what we'll do is we just simply plug this into our calculator. If you multiply this by hand, you have 36 pi over 5. When you plug it in your calculator and round it to the nearest inch, you are going to have 23 inches as your arc length. Okay, so answer is option number 2, 23 inches. All right, let's take a look at the last problem in the multiple choice section. 27 reads, if f of x equals 4x squared minus x plus 1, then f of a plus 1 equals. Now, one thing you want to note when evaluating a function as an input value is that parentheses serves as a protection. Okay, it serves as a protection against sign or order of operation errors. So please, whenever you're evaluating a function at an expression or at a numerical value, please use parentheses to avoid making errors associated with sign or the order of operations. All right. Okay, so step number 1. First of all, we're going to substitute a plus 1, the input of this function, into the function. Wherever you have x's there, you substitute f of a plus 1. And then step 2, we're going to simplify the expression using the order of operations. All right? So let's go ahead and carry out the process. Step 1, we're going to carry out the substitution. What goes where? Well, let me color code this function for you so you see where we are going to be inputting the argument for the function. So f of x is equal to 4x squared minus x plus 1. Okay, so what does this mean? What this function does is that it inputs x into this. You square x multiplied by 4 minus x plus 1. Okay? All right, so with this in mind, what is f of a plus 1? What is this? This simply means wherever you have x in your function, replace it with a plus 1. We're evaluating this function at this input value. In this case, the input is an algebraic expression. So instead of x squared, we're going to have what? A plus 1 quantity square. Minus, instead of x, we'll have a plus 1. Please note how I'm making use of the parentheses here is for safety reasons to avoid making mistakes. All right. Okay, so this is step 1 where you basically substitute a plus 1 to all the x's in the function. Now step 2, we'll just simply simplify this expression using the order of operations. All right. So let's go ahead and do that. We have to resolve the powers first. So 4 times a plus 1 times a plus 1. Anytime you have minus in front of a parenthesis, please proceed with caution because signs switch to the opposite when you have that situation, okay? So when you divide minus to a, you have minus a. When you divide minus to plus 1, you have minus 1 plus 1. All right, so these two last numbers are opposite, so they add up to 0. And then we can FOIL this out right here. We have 4 times a squared plus a plus a plus 1. Okay? And then minus a. This a is looking like a 9. That's not good. Can't afford to do that. Okay, so we have that there. And then we have 4 times a squared, combine the two terms in the middle, 2a plus 1 minus a. Now we can distribute 4 to all three terms. So we have 4a squared plus 8a plus 4 minus a. Okay, now just simply combine 8a and negative a. That should give us our final answer, which is 4a squared plus 7a plus 4. All right, so that's f of a plus 1 given the function, and our answer is option number 4, 4a squared plus 7a plus 4. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found this tutorial beneficial to you, please give us a thumbs up, a positive feedback that we'll appreciate. Um, if you Have not already done so, please subscribe to our channel so you can get updates to the remainder of this review series. If you have any questions or like support with any questions in the Algebra 2 Trig Regents review, just put a comment in the comment section below and we'll be glad to address it as soon as possible. More clips can be found on mathgotserved.com under test prep. Thanks again for watching and have a wonderful day.